There are two aspects to mental computation, and both have a place in mathematics, but they differ a lot in their purpose. So the first is mental arithmetic, and it's the one that you may be most familiar with. It relies on memory, and the purpose is a rapid recall of number facts. The second is mental computation, which we're going to talk about today. It relies on thinking and being able to use strategies to estimate and solve number problems. Joe Bowler from UCube describes mental computation as solving maths problems by breaking numbers apart and putting them together in different ways, which I think is a great visual. I've included a link to her video. Other ways to think about mental computation are using a range of strategies to solve number problems, estimating answers and finding solutions, being challenged to think about maths in new ways, and having number sense and being able to think flexibly and creatively. I wonder how you think about maths. If you would like to pop those words in, we'll come back to those later, but I wonder whether any of these descriptions resonated with you or not. Students may think that mental computation is only useful if they want to do a math-related job, such as accounting or engineering or computer science. However, it's a skill we use throughout our lives. So just to warm up, I'd like you to use the chat panel and tell me one way you use mental computation to solve a problem today. And then Mandy will monitor the chat box and tell us some of the responses that you put in. And you can see there are a few prompts on the screen to help you think. Give you a moment to do that.
All right, Stella, we're starting to get a few responses in. Jocelyn says she was dividing notes up to play a musical composition. Renee said budget for the week and the month ahead. And Libby said shopping. Robin was helping the PNC work out the unit price of canned drinks for a barbecue. Hayley says time management, working out how long I have to get a snack before the webinar starts. Karen says cooking times. Anne says scheduling time.
Well, that's great, Mandy. There are so many ways that you use mental computation every day. Some of them you've already said, but everything from managing your money, which I'm sure we all do all of the time, to paying bills, buying groceries, making things, baking things. Some of you mentioned that. Whether it's carpentry or dressmaking, that involves maths, and shopping, working out the best bargain, comparing costs per grams, weighing products, and of course at work, and we had some good work examples as well. So I think it's important that students understand that mental computation isn't just for those who want to be doing a maths related job, but is useful for every day. So let's look at the sequence of learning multiplication and division. So multiplication builds on addition, and before students are ready to learn multiplication, they need to know their addition facts and be able to use a range of addition strategies such as count on, doubles, and 10 facts and turnarounds. Students learn subtraction next by relating it to addition, and they must be confident with addition before learning subtraction strategies such as count back, that is, start with a big number and count back to the small number. Count up, which is start with a small number and count up to the big number. Use doubles, the 10 facts, and take 0. Students then continue to learn related strategies for numbers up to 1,000. We won't go into these strategies today, but please indicate in the chat box if in the future you would like a webinar on addition and subtraction strategies. So multiplication builds on addition, and students can apply addition strategies such as doubles and count on to multiplication. The three main strategies introduced in the early years are skip counting, making and counting equal groups, and using arrays to represent multiplication in different ways. Students will also explore multiplication strategies such as turnarounds, that is the commutative property, using known facts to calculate related multiples, and using place value to decompose numbers before multiplying. So think about the definition of breaking numbers apart and putting them together in new ways. Division builds on multiplication using mental computation strategies such as think multiplication, arrays, and skip counting. For example, for 12 divided by 3, students are encouraged to think 3 by what equals 12. I want to show you some vocabulary used to describe division. So dividend is the number being divided. The divisor is the number the dividend will be divided by. And the quotient is the number of times the divisor will go into the dividend. They're probably the three terms that tend to be quite problematic with students in schools. And you can see how these concepts come much later than addition, subtraction, and multiplication. Students will learn two methods for division. Partitive division is when we know the number of groups and want to work out the number in each group. For example, 36 students are travelling to the swimming carnival by minibus, and there are 3 buses. How many students will travel on each bus? To do this, you could visualize students walking one at a time to the buses. Quotative division is when we know how many in each group and want to work out the number of groups. This is repeated subtraction. For example, 36 students are travelling to the swimming carnival by minibus. Each bus can only take 8 students. How many buses will you need? To do this, you could visualize putting students into groups of 8 and counting the number of groups. Notice that quotative division is similar to the word we just looked at before, quotient, and that's because you use that method to do long division. The National Numeracy Learning Progression will be phased into all schools from this year, and it identifies a sequence of observable indicators that show how numeracy develops over time. So if you want to know more about the sequence of learning numeracy, I would encourage you to talk to your teachers about that. Today we will look at how to use groups, arrays, and skip counting to support students with mental computation. Along the way, I'll share with you some ideas for you to try with older students as well, as I know that you work with a wide range of ability levels and ability groups. Learning multiplication and division begin with many informal experiences, making equal groups and counting how many altogether, such as creating patterns with beads, building with Lego, sorting and matching games, counting eggs and egg cartons, sharing with friends, and baking and decorating.